Bismillahirrahmanirrahim. Assalamualaikum. My name is Muhammad Izam bin Ahmad Nazri. Today, our group will present about operational research. We are giving a project assignment. Okay, this is our group members. Start with Muhammad Shamim, Muhammad Solih Nafizi, Ahmad Ani Akram, and Muhammad Izam, myself, and Aiman Zakwan bin Azhan. There are three topics are given in this assignment, which is for the question one is transportation model, and second is project management, and the third one is linear programming. Okay, thank you. And I will pass to Mr. Solihin to continue to his part, which is transportation model.
Assalamualaikum, and my name is Muhammad Solihin Hafizi bin Yunus. So I will explain about transportation model and how to solve it. First of all, we go to introduction first. Introduction for transportation model. To minimize the overall cost of transportation, the main objective is to strategically identify the best quantities to be delivered from each source to each destination. This called for a careful allocation procedure that consider how supply capacity and demand requirement interact. Okay. Through through the methodical application of linear programming tool, organization may effectively tackle this difficulty and develop distribution strategy that match demand while maintaining the lowest feasible cost. Thus, the transportation problem become a useful tool for company looking to improve resource allocation, streamline their logistics, and eventually maximize their distribution network. So we go to the question about the transportation model or transportation problem. So how to solve it? From the question, he say use the northwest corner method and then find an optimal solution. First, we need to solve by northwest corner method first. First of all, step one, set up the initial basic feasible solution. So this is a table for basic to find the northwest. So northwest is start from the left side of our hand. So that means start from the transportation cost is 11, row A and column D. Okay. On this example, okay, we see that requirement need 200 and available is 250. So it's enough to cover the requirement. So we put 200 and the balance at requirement is 0 because all have distribute from available. So that at available, so left in 50 because we have give to A, row A column D 200, and then in row B column D and row C column D we cannot give because requirement requirement already settled. So we mark X. So we go to the row E and column E row A, sorry, row A and column E. Row A and column E need 225 requirement. So balance supplier at column A is 50. So we need to put all the 50. So our row at supply at row A has become 0 because we have give to we already give to column D and column E. So after that, requirement at column E left 175. So we go to next step. we look at row B and row B column E, like that. Five. So requirement left at of row column E is 175, and supply available at column B is 300. So we give the balance all because it enough to cover the demand. So available at so supply at column B left 125. So at, row D, row C, we cannot give we cannot sorry we cannot give because the requirement is 25 and 225 already give to row A and row B already. So the total is 225. Can you see? Uh, for the column F, column F and column G for the row A, we also cannot give because we not have enough. We have not enough demand. And sorry, we not have enough supply or to give because is become zero. So we go to the next step. We repeat the same thing. For the step 5, we look at the cell BF and give. We repeat this step until all the requirement. We repeat all step until the requirement are satisfied, and we can calculate transportation cost. So how to calculate transportation cost is compute by evaluating the objective function. So this formula Z is transportation cost. So we look at a column that have value. In small box is transportation cost, and multiple with the the value the value that we have distribute the demand. So for example, look at row A, column D, 200 demand, and transportation cost is at 11. So we need to multiple these two, and after that, after we already multiple all the column and all the box all the box have a value, so we need to plus. So the answer is 12,200. So this is our answer or cost for northwest corner method. And then we need to find optimal solution. How to find optimal solution is we go to the next step. So how to find optimal solution is we need to using by distribution method or all Modi method. So we need to for the row we need to divide U1 for A, U2 for B, and U3 for C. And for column D, VD, EVE, F, VF, G, VG. U U mean for column row, and V mean for column. So when this is as a formula. For example, AD, column A, row D. How to find? U1 plus VD equal to 11. 11 is transportation cost. Okay, we'll go to another example. Column row A, column E. Okay, so column A, row A is U1, and then V VE mean to column E. So equal to 13. 13 is transportation cost. Okay. After we list all this, we go to the next step. So we need to find the value. Okay, how to find the value? U1 equal to 0. First of all, how to find VD? U1 is 0, so plus VD equal to 11, and the total is 11. So we can see how to find U2. Okay, how to find U2 is U2 plus VE equal to 18. 18 is transportation cost. So U2 we don't know the value, but VE we already know the value. VE is 13. So we put 13 here equal to 18. So 18 minus 13 equal to 5. So U2 is 5. It also same the step is also same step to find U3. Okay, we look at HCF. How to find U3? U3 plus VF. Value VF is 9 and equal to 13. So U3 plus 9 equal to 13. So we move 9 to the behind and become minus. So 13 minus 9 become 4. So U3 is 4. After we already find all the value, so we can go to the next step. So this is a table after we find the value. You can as you can see, U1, U1 equal to 0, U2 equal to 5, U3 equal to 4, VD equal to 11, VE equal to 13, VF equal to 9, and VG equal to 6. Okay, so after that we need to calculate empty cell, empty cell that have no value. How to find? So we need to use this formula Cij minus Ui minus Vj equal to Kjj. Okay, Cij Cij is a transportation cost, Ui is a row, and Vj is a column. For example, the empty cell is row A, column F or column F. So 17, the transportation cost is 17 minus U1 is 0 minus 9 minus 9 9 is minus 9 9 is a column VF, so equal to 8. So after we calculate the all empty cell, so we need to find a negative value. So that here negative value is negative 1. Negative 1 at column G, row B. So after the next step, if we need to use stepping stone, how to use stepping stone? Stepping stone is we need to move to to the to the nearest value, to the nearest cell that have value. So this is a cell that have a negative value. So we move to the left left cell, which is 125, and we cannot move we cannot move to the left of 125 because we cannot return to the negative value cell. So we need to move to the down, which is 150, and then move to the right 215 and move back to negative value cell. So as you can see the arrow, after that we need to put the sign negative, sorry, positive, negative, positive, negative. Reminder, we need to put sign positive first at the negative cell. We start. So as you can see, we put positive, second row negative, third row positive, and the fourth row negative. After that, after that, we look at the negative sign and look at the value that has the smallest. So between 250 and 125, the smallest value is 125. So we pick up the 125 value. So after that we look at the sign. So at the sign positive, we need to plus 125. Negative and negative sign, we need to minus 125. So the answer is like that. So as you can see, negative value cell that have negative value yearly become 125, and the value that has smallest, we pick up become zero, because 125 minus 125 become zero. So this is the answer for stepping stone. So ready, we can find transportation cost. So how to find transportation cost is same, is same at the step at Norwest corner method. We need to value multiple with transportation cost. So after multiple all the value, and we need to plus all the value and become, and the answer is 12,075. So this is a optimal solution. So as we can see, when the total cost is lowest than lowest method is, so this is optimal solution, because at the lowest corner method, the total cost is 12,200, and this optimal solution answer is 12,075. So this is optimal solution. We also can check the answer by recomputing the value. How to do? Okay, so we need to recomputing ui and vi. Ui for row and vi for column. It's the same step. We look at the column A and row D first. So U1 plus VD equal to 11. 11 is transportation cost. Okay, so we need to calculate same U1. U1 equal to 0. After that, we also need to calculate empty cell. Same formula. Cij minus Ui minus Vj equal to Kgj. So we know the answer is correct when the total, when the total from the we minus no negative value, so the answer is correct. As you can see, we do not have negative value. So that's all how to solve Norris method and find optimal solution by using Modi method. Say okay, for transportation model, for the conclusion, the transportation challenge seek the most cost effective way to distribute good from supplier to customer, ensuring demand satisfaction. This optimization thus aim to minimize overall transportation costs, including monetary, time, and other relevant factors. It involves allocating resources wisely, with each supplier and customer having specific capacity and demands. The transportation problem, often framed as a linear programming issue, the transportation problem find application in manufacturing, distribution, logistics, and supply chain management, helping business enhance operational performance through cost saving and efficient resources utilization. That's all from me about transportation model. Thank you.
Hi, Assalamualaikum, and a very good evening to my lecturer, to our friends. Hello, my name is Ahmad Zakwan bin Azahan, and I would like to explain about the project assignment, which is subtopic project management. Okay, for without further ado, I will talk about the introduction of the project management. A network diagram is a graphical representation of a project is composed of a series of interconnected is of a series of connected arrow and boxes to describe the interrelationship between the activities involved in the project. Okay, project management is a must-have in an organization so that they can follow the flow without any interfering the activities, and also it can act as or view as activity that are connected with each other using arrow and boxes to describe, to verify, to explain the relationship between the activities that are involved in the organization or project. So the question is, all this information can be presented by network shown below. So there are 14 activities, which is A, B, C, D, E, F, G, H, I, J, K, L, M, N. Find the critical path for each activity network. Find ES, LF, ES, EF, LS, and LF. I'm sorry, my bad. Okay, ES stands for early start, EF stands for early finish, LS stands for latest start, and LF stands for latest finish. So, how to solve this question? So, my friends, Muhammad Shamim will be explain and present on how to solve this question. Thank you.
Hi, my name is Muhammad Shamim. So we're going to solve the question two. The question is to find the critical path in all activity. So the first path is ADHM. The total weeks is 90 weeks. Number two is AIM. The total weeks is 17 weeks. Number three is BEJM, 21 weeks. CFKN, 16 weeks. CGLN, 20 weeks. So the maximum time is 21 weeks. Therefore, the critical path is B, E, J, and M. Okay, move to the next question. This time we need to find ES, EF, LS, and LF. ES is earliest start, EF is earliest finish, LS is latest start, and LF is latest finish. So you can see in the box, based on the question, the letter represent the time of the activity. So A 6, D 4, H 3, M N. That's for example. So put all the numbers beside the letter in the box. The four box represent the ES, EF, LS, and LF. Okay, so the earliest start for all the first box A, B, C is 0. Then add with the numbers beside the letter A6, B3, C4, add with 0, then we get the earliest finish time, which is 6, 3, and 4. Then the 6, we go to the next path, D, and then we get 6. Then add with the number with 4 beside D, then we get 10. We get the earliest finish. Then 10 carry to H, 10 plus 3, then we get early finish, 13. Then 13 we cannot put all the way to M because we also got two box I, J that we not yet count. So we count A, I, and M. The earliest finish for A is 6, so we put 6 in the earliest start of I. 6 plus 5, then we get earliest finish 11. Then we go for B. 0 plus 3, 3. Earliest finish 3, we go to E, put to the earliest start. 3 plus 7, we got earlier finish 10. Then 10, we carry to J. J put 10 plus 4, then we get 14 for the earliest finish. Then to get the earliest start for M, we choose the highest number, which is 14. So 14 put to the earliest start for M. 14 plus 16, then we get earliest finish for M. So we get 20. Then we go to the box C. Earliest finish for C is 4. So 4 we put to the G, we put to the F. Then we get earliest start for F. 4 plus 4 we got earliest finish for F. 8. 8 then we put to earliest start to K. 8 plus 3 we got 11. Then we go to the G box. Earliest finish 4. Put to the G. 4 plus 6 we get earliest finish 10. 10 to earliest start L. 10 plus M 15 for earliest finish for L. Then we choose the maximum we choose the highest numbers 15. Then we put to the N. So the earliest start for N is 15 plus 15. Then earliest finish for N, 15 plus 5, we got 20. Then to get then we need to find the LS and LF, latest start and latest finish. So we have to minus the numbers backward. So the earliest finish for M is 20. 20 minus 6 we got 14. So 20 plus 6 14. Then the N 20 minus 5 we get 15. So the latest start for M is 14 and the latest start for N is 15. Then the 14 we put to the latest finish for H, I, and J. Then 14 minus 3 we got the latest start for H, which is 11. Then 11 we put back into the latest finish D. We got 11 minus 4, 7, the latest start for D. Then 7 we put to the latest finish of A. We got 7 minus 6 for latest start of A, 1. Then the box I, 14 minus 5 we got 9. Then 9 we cannot put to the A because the lowest amount is 7. So 7 we put to the latest finish of A. Then we go to the box J. 14 minus 4 we get latest start 10. Then 10 we put to the latest finish of E. 10 minus 7, we got 3. 3 go to the latest finish of B. 3 minus 3 equals 0. Then N, 15. 15 we put to the box of latest finish K and L. To find the latest start of K, 15 minus 3, we got 12. Then 12 put to the F, 12 minus 4 to get latest start of F, 8. Then the L, 15 minus 5, we got latest start of 10. 10 we put to the box of G, 10 minus 6, we got latest start of G, 4. Then we can determine that 4 is the lowest amount. So we put 4 to the latest finish of C. 4 minus 4 equals 0. So now we need to find the slack time. Uh, the the solution is EF minus LF and ES minus LS, which is if you find the same amount of difference, so the slack time is right. So for example, box M, 20 minus 20 equal to 0 and 14 minus 14 equal to 0. So the slack time is 0. So if the both box minus the equal amount, then your box is correct. So if your slack time is more than 0, it is good. Slack time is the amount of time you can delay the task without interfering with another task or affecting a completion date of your project.
Hello, assalamualaikum, and we meet again. Thank you to my dear Shamim, because on how he explained about the question, on how to solving the question. So, without further ado, for the next part is conclusion for the question two. So, project management is a valuable tool for project managers and team, as it can help the project manager and team to efficiently process the project or activities without any delay. Um, it enhances the communication among stakeholders, facilitates decision making, and enable proactive management of project constraint. Project management can also act as a decision making if there are any project have been on stall, so that there are no project will be left hanging without being completed. Last but not least is an essential component in successfully managing projects and ensuring timely and successful project completion. Basically, it means that project management without these tools, it will be hard, but still complete. But it can be considered hard, as project management can efficiently, smoothly the project, without any interrupting, without any delay, without any making a major big mistake, so that the project can ensure the project can complete timely without any delay. Thank you.
Hello, Assalamualaikum. My name is Muhammad Izam. Today I will present about the the third question, which is linear programming. Okay, linear programming optimize resource allocation in diverse fields like scheduling and finance. Linear programming involves decision variable and objective function and constraints. It's about finding the best solution within limitation, akin to solving a puzzle. LP helps make smarter decisions and solve complex problems efficiently. Okay, this is for introduction. Okay, now we will go to the question. We are giving a question about linear programming. Okay, for the question, I will read this question, which is to go down, A and B have grain capacity of 100 quintals and 50 quintals respectively. This apply to three ration shop, D, E, and F, whose requirement are 60, 50, and 40 quintal respectively. The cost of transportation per quintal from the go down to the shops are given in the following table. Okay, we can see the following table here, which is from D to A. The cost per quintal is 6, and E to A, cost per quintal is 3, and F to A is 2.5. Okay, from D to B, we can see cost per quintal is 4, and E to B is 2. And the last one, the cost per quintal is F to B is 3. Okay, the question is, we need, how should the supply be transported in order that transportation cost is minimum? What is the minimum cost? Okay, we will go to the solution part. Okay, we in the solution part, we can see here that let be a to d equal to x, a to f equal to 100 minus x minus y, a to e equal to y. Okay, for the b is b to d equal to 60 minus x, and b to e 50 minus y, b to f equal to 40 minus bracket 100 minus x minus y bracket. Okay, for the objective, we can see here to find the minimized p is the first one is p equal to 6x plus 3y plus 2.5 plus bracket 100 minus x minus y bracket plus 4 times 60 minus x plus 2 times 50 minus y plus 3 times 40 minus bracket 100 minus x minus y bracket. Okay, for the last, after we calculate it, we can see here the P is equal to 6 minus 6x minus 2.5x minus 4x plus 3x. We get the x is 2.5, and we will plus, and we get for the y is 3y minus 2.5y minus 2y plus 3y, we get 1.5y, and 100 plus 120 minus 300, we get 410. Okay, for the minimized p, we get 2.5x plus 1.5y plus 410. Okay, this is the uh, s- uh, it will this part will help us to see the path or road in easier way. We can see here there are capacity A is 100 from A and capacity 50 from B. Okay, for the subject to constraint. Now, since go down A can supply maximum 60 quintal to ration shop D and 50 quintals to ration shop E and have maximum 100 quintal capacity to supply. There are three subject to constraint we can see here. Okay, for the subject to constraint is x plus y less than or equal to 100, x less than or equal to 60, y less than or equal to 50, x plus y greater than or equal to 60, x and y greater than or equal to 0. Okay, for the next part, I will pass to Akram. He will tell more about y-axis and x-axis here. Thank you. That's all for my part.
Hai, Assalamualaikum warahmatullahi wabarakatuh. My name is Ahmad Hanif Akram Nurisi Asmat. My number ID is 57212222 So right now I will continue the linear program. The next step is a linear program. So kita ni what the exam presenting. So next we should find the value of x and y and the value must be the greater or equal to 0. So the number must be positive lah. Alright. Next, the value of x and y, we just to find in the constraint x plus y less than or equal to 100, and also x plus y greater than or equal to 60. Alright, so next, this constraint we put in the equations to get the value of x and y. Alright, so x plus y equal to 100, and the next step is we put x or y into the value 0. Alright, so when x is 0, so y is 100. So when y is 0, x is 100. So this must is simply equation lah. So we don't need to divide or what, because this is a direct equation. So easy to us to make or to find the value of x and y. So x, when x is 0, y is 100, and when x 100, y is 0. So the next equation is we get from the constant, which is x plus y equal to 60. So when x 0, y is 60, and when y 0, x is 60. So right now we have 2 points. So we can plot the line at the graph. Not 2 points, we have 4 points actually. X, Y, X, Y. So when x is 0, y 100, so we can plot in the graph when x 0, y 100, this first point, and y 100, x 100, y 0 in this point. So when we have 2 points, so we can draw the line. Alright, so this is the first constraints to this line, and next is this one, x0, y60, first point, x0, y60, then x60, y0, x60, y0. So this is a 2 point, and we make a line. So this is a second constraint, which is x plus y greater or equal to 60. So the next line in the graph is, which is x less than or equal to 60, or y less than equal to 50. So we do not need to find the x and y because it is direct equation. So we dah jumpa pun okay, this x and y, right? So x is 60, y is 50. Alright, so x is 60, so this direct line, and this is y50. Okay, so next steps, we must find the feasible regions, okay, feasible area. So how to find is we check the constraints, either they're less than or greater than, and with that things we can know the feasible regions. Okay, so the tips is someone will get confused about this. So the tip is when the equation or the constraints have less than or equal to, so the feasible region, it must be below the line. So alright, but if the constraints show the greater than or equal to, so the feasible region must be above the line. Alright, so in these questions, we the first constraint we have below the line, which is because they're less than or equal to, so the feasible region is below the line. And the second constraint is above the line because they're greater than or equal to. Okay, so the feasible region must be in here, but in the third constraint we have x less than, so we must left in this. Okay, so in this must feasible region must left because of the constraint is less than or equal to, right? So the feasible region must be in here, and the last constraint, which is y less than or equal to 50, so must be the below the line. So we find the feasible regions in here, and if we look at the feasible region, we have four corners. The corner A, B, C, D. Alright. So it's a feasible regions. So the value of each corner, A is a 10, 50. B is a 60, 0. D is a 60, 40. C is 50, 50. Right. So after finding the feasible regions, we need to substitute this value corner value, which is A 1050, B 60, 0, and the rest. We must substitute this value corner in the objective functions. So objective function, this is first step we must get. Uh, okay, so what the objective functions in this question, which is 2.5x plus 1.5y plus 410. Alright, so we must substitute, which is a their x is 10 and y is 50, so we just substitute 2.5 multiplied by 10 plus 1.5 multiplied by 50 plus 410. Alright, okay. So the answer is for A, for the corner A is 510, for the corner B 560, and the corner C is 610, and the corner D is 620. Okay, so why we must substitute this corner point to the objective function? Because we need to substitute is in order to finding the optimum point. Alright, so the optimum point and optimum value. Okay, so the optimum points in this question is 510 because of this is the lowest value among the points. Alright, so the minimum value of the objective function p occurs at x 10, y 50, which is corner points A. Hence, the optimal solution is point 10, 50, and minimum p is 510. So that's all from me for this question. So what we can learn for this subject is LP is optimized resources allocation and decision makings. Especially for this question with graphical methods. So it's address challenges in productions, inventory management, and resource allocations. And the last one, what we can get from this chapter is, despite its limitations, LP remains indispensable, involving with computing advancements, enhancing efficiency, reducing costs, and achieving strategic objective. So that's all from me and from us. Thank you very much.